Good afternoon, everyone. My name is Nishi Chaudhary. I am graduate research assistant at Colorado State University. Today, I'm presenting our research, how reliable are large language models, zero-shot detection of construction hazards, authored by Dr. Uddin, assistant professor, Colorado State University. Mahzaba Tamanna, graduate research assistant, North Carolina State University. Dr. Alex Albert, associate professor, North Carolina State University, and Dr. Abdul Rahman bin Zahid, assistant professor, Southern Illinois University. Starting with bigger picture, construction plays important role in developing infrastructure and shaping our broader societies. Yet it remains to be one of the most hazardous industries and continues to report disproportionate amount of safety incidents around the world. The numbers are quite alarming. In USA alone, about 1,000 fatal injuries and more than 200,000 non-fatal injuries are reported annually. Research suggests that uh, about major reason of these safety incidents are failure of hazard detection, as 70% of incidents are caused by poor hazard identification. Years of research has been put into developing tools like job hazard analysis, safety checklist, yet using these tools, about 40 to 60% of the hazards remain undetected on site because of their limitations, like being task specific or being able to detect only limited number of hazards. Coming to technological solutions like BIM, AR, VR, eye tracking, etc., tools are definitely more reliable, but they have their own limitations. Like they require longer development time, they require expertise, and they most importantly they are expensive, and not all contractors can afford it. So we need more accessible, scalable, and low cost tools. Since the widespread use of LLMs, specifically ChatGPT, there have been lots and lots of research going on to explore the potential of these large language models. There have been research says that suggests that shows the improvement of about 40% when large language models are used during hazard recognition efforts during the design phase. Similarly, there is a research that where virtual reality based safety model was developed and using LLM, where AI served as online instructor, and the knowledge score was increased about 23%. But the problem with all this research during all these years is that they only focus on a single large language model, and which predominantly focuses on text inputs and outputs, while we have numerous models that we use in our field, and they are also able to take visual data as their inputs. So the objective of our research is that we create a framework where we test 5 large language models and evaluate their reliability and efficiency to analyze visual input for hazard recognition. Talking about our methodology, we started with a dataset preparation. We collected 16 different construction images from different sites, different projects like residential, commercial, roads, etc. It was also necessary for us to develop a ground truth so that we can compare our end results to the ground truth. For that, we had expert panel of 17 safety experts who have the collective experience of 300 plus years. Then the expert panel developed a ground truth with a 120 hazard. Then we move on to the selection of large language models. The large language models that we have used are GPT-4, GPT-4o, GPT-o1, Gemini, and Claude. These models were selected on the basis of their popularity and also their ability to intake visual data as their input. Then we gave these models a standardized inputs. And finally, we compared the data, the outputs of LLM with our ground truth, and used the evaluation metrics like precision recall and F1 score, and hence made our conclusion. This is one of the images, one of the 16 images that we used as our data set. In this example, in this picture, we can see that there are different kinds of hazard that were determined by our experts, like motion, temperature, chemical, mechanical, etc. Talking about the prompts that were given, we explored a zero shot. We gave a zero shot prompt to our models. There was no extra fine tuning or um, uh, outside input given to the prompts. We just said that you are a safety expert. We are going to give you the image and try to identify the hazard as you can. And we evaluated the data on the basis of precision recall and F1 score. And these were the equations that we used with the parameters of true positive, false negative. Talking about the results, we can see that with the zero shot prompt, we have the scores that precision recall and F1 score that lie around 0.25 to 0.42, where we can see Claude has the highest precision score of 0.42, while the Gemini has a recall score of 0.33, and the F1 score, the highest F1 score is 0.34 by Claude. These are the top 5 hazards recognized by these models are struck by, excavation, confined space, etc., while the least 5 hazards that were determined by the models were noise, weather, ergonomics, etc. So what do we conclude? As we can see that in machine learning, the acceptable scores is about 0.7 to 0.8. So we can see that with zero shot prompt, these models are not very reliable. But what is interesting is when similar kind of research was performed with human subjects, they all, without any the inexperienced construction workers, they also showed about 35 to 40% of accuracy when they were done when they were not initially trained. But when they were supported, when they were trained with LLMs, their accuracy increased to about 70 to 80%. And even with even the types of hazards that LLMs missed and was determining was identifying mirrored the behavior of human subjects. So here with this research, we are suggesting that when and AI should be AI should be for a better and enhanced performance.